My name is Alejandro Cepeda, and this is our alarm system presentation for ECE 1, and this is our final. As I said, my name is Alejandro Cepeda. For my role in this project, I was the spokesman and the manager.
Hello, my name is Julian Flores, and I was one of the spokesmen in this project.
Hello, my name is Samuel Delgado, and I was a manager for this project.
Hello, my name is Branson Stokes. For this project, I was also a manager.
Hello, my name is Isaiah. I was a reporter for this project.
Hello, my name is David, and I was a reporter also.
Hello, my name is ECE, and I was a reporter for this group project.
All right, for our problem statement, it was simple. It was to create an alarm system to prevent break-ins in households. When starting with this project, we wanted to start off with our background and our brainstorming. We wanted to create an alarm system that protects a household when unattended by homeowners and when unaware of intruders. While brainstorming with an alarm, we wanted to keep the basic needs of a typical alarm system. This typically included protection to doors, windows when open while alarm is armed. We also wanted to get a little fancy, so we did some research and came to the conclusion that we should add a camera that records and detects motion to alert the homeowner when someone is near.
Okay, so the motivation behind our project, it was a topic that was previously brought up in class. This summit not only just seemed interesting in and of itself, but it was, while we had been learning it, it also seemed more accessible to us because we are all beginners at this kind of work. The cameras and the motion sensors, along with the new circuits that we've been working on in Tinkercad, all caught our eyes very quickly. It just seemed much more interesting than any of the other toppings, and it was a pretty good learning opportunity as well. And overall, our motivation for the project was for the future of this kind of work for home protection use, as Samuel stated.
So in our project scope, some key information that we did was the full participation in getting the project done and correct. For example, we did this as a group, and so doing it individually will be more harder, but in a group, it was much easier, and we could get things done more faster. And we also adjusted our schedules where we figured out like what schedules each person has and how we could find the perfect time in meeting and working on this project. And also the communication, we used an app called Discord where we messaged with each other and seeing like what needs to be done, and yeah, with the project. We had an idea on which project to choose from all the projects presented. So before like the projects were presented, we had an idea of the home alarm system since in the class we had a lecture about it, and we wanted to like elaborate it more and go into it and see how it would like be in the end and how everything will work. While we couldn't meet face to face in our groups, we made a great job in communicating through Zoom. And even though it was not face to face, it was no less difference than meeting in Zoom. Here and after of this project, we will implement this home alarm system in software such as Tinkercad or Multisim and visualize the circuits and how it works. And also we will it's like a step in our careers and what we'll be doing like in the near future. And yeah.
So for the timeline of our project, in total we had 6 meetings and some in between meetings, but we didn't count those. Also, most the reporters in our project took notes in all the meetings that we held. So the first meeting was basically trying to figure out like what we're gonna do on the project and how we're gonna achieve it. And the first day was also when we discussed our roles and who was gonna do what. The second meeting was when we defined our objective in the project. We also started brainstorming ideas of like what the variables would be, like the doors and windows, for example. And this is also the day that we started the truth table. The third day, we had to refine our truth table to be more accurate, and we also figured out how the circuit would look, and we sketched our first design for the truth table. On the fourth meeting, we had to decide like which software we would use, and since we're most familiar with Python, since it was more easier for us and we were more comfortable with it, we tried that, and we also tried to implement our variables into the software and try to connect the hardware to the software. For the fifth meeting, that was the day that we went over the software and truth table to make sure everything was correct. And it was also our first presentation that we did for the project. We also decided on how we're gonna split up the presentation and who said what. For the sixth meeting, it was the last meeting, and we discussed on how we were gonna present our final presentation and who was gonna say what again. And we also tried to incorporate a circuit from DignaCAD into our project. And all the meetings that we held had full attendance and full participation. That also helped our project move more smoothly. We also had, like I said before, we also had some meetings in between, but not everybody could make those, so we kept them brief and we didn't count those in this.
So for the main description of our project is one way we would actually help our project move along smoothly is by using Boolean logic throughout the whole entire project. And like I stated previously, we used Python as our code. So a description of our project was, the point of it was an alarm system to alert the homeowner if there was a break-in or possible suspicious movement around their house. If there was a break-in, then our alarm system would have notified the homeowner and police in some way to alert them and to tell them someone broke in. The thing is about receiving the system for the first time, you need to manually activate it to have the system start up before it starts to work properly.
And now moving on to the hardware design aspect of our project, we chose to go with, like Julian has stated before, a truth table and Boolean logic to represent the wiring. The 5 variables we had were door 1, door 2, window 1, and window 2, and camera. Or these variables, as you can see here, D1, D2, W1, W2, and C respectively. We used OR gates as a visual representation for an alarm system wiring, and we combined all of the doors and windows and with the camera with an OR gate. This is to determine if the alarm should go off. Our outputs for our system were lights, siren, and notifying authorities, or LSN for short. And you can see this here in this document we have made. This displays our truth table. So we can see we have the 5 inputs right here. And we also decided a little change from the last presentation that we had. We decided to lump together camera and motion since they effectively do the same job. They are able to detect motion within a certain area of the house. And in our first column here, our first OR gate, we have the door 1, door 2, window 1, and window 2 being added all together. So in this instance, you can see since there is no activity in these 4 variables, these are 0. It is not until we have at least one of these active where this column becomes a 1. And then at the very end, as stated before, we have all of those variables. And with an OR gate, we added cameras to it to also ensure to see if the alarm would go off. As you can see, at any instance, the system would go off if anything is active. The only time the system would not activate is if there is no input from any of the 5 variables whatsoever. And we had the 5 variables counting from 0 to 31 in binary, representing the first 5 rows here, as you can see. And here is our first sketch that we have of our wiring diagram. Here we have the variables, our OR gate being added, and then we have that variable being added again to the cameras. And we have our end result of LSN. Now, something new that we decided to try here, we decided to make a circuit on Tinkercad with the help of Branson and a few others, as they've had a little more experience in this simulation more than I have. It was a joint effort where we have a 3-volt battery connected. Here's the ground, and here's the positive. This is our little panel. It represents the variables, as all you can tell they're off right now. This is our AND gate with all the inputs and outputs connected. The ground is connected to the negative here. And we have our sensors here, our light and siren. And we're gonna try this out. We're gonna hit start simulation. As you can see, with no inputs, none of these should go off. But the minute you hit any combination of these two, we have one of these lights going off, symbolizing that the alarm is going off. So we turn this off, we turn this one on, these 3 on, siren goes off. As you can see, turn all 4 of them on, both of them go off, lights and siren. So this is a little representation. It's just a rough sketch right now. This is going to represent our wiring aspect of the project.
And now for this part of the project, the software aspect, basically we created it all on an online GDB, which is the name of the website, which is an online compiler where we use Python for our programming since it was the coding language I was most familiar with. And all the following code was created using prior coding knowledge gained from my personal experience back in high school when I took 2 years worth of coding classes, except for the random number generator. For that, I used open source, and I was able to find a code that Python created in the years past, and I implemented that. And now I'll share my screen to demonstrate how the live code works and describe what each line of code does and its purpose. Share screen. All right. So go into the online compiler. We have a couple of hashtags which represent the common coding aspect of this project, and it describes most of the things that are implemented. But starting from the very top, we have a couple of imports from time import sleep. Sleep is used in the sleep functions down here in order to make the program more realistic and give time for the systems to actually check all the individual values. We have math functions, so we could use modulo properly here and also have some later division going on down in the code. And we also imported random. Random was for the random.range function in order to make a RNG and to basically make all these variables here, as we discussed previously in the hardware aspect of this project, in order to make it randomly true or false around 50% of the time, just for the sake of example and simulation. And then going on to the first print statement, it's just a greetings prompt to the user. Welcome to your smart home alarm system. Using this interface, you can either arm or disarm the smart alarm system. And then after this, we ask for the user input to please either type in activate or deactivate into the interface or the panel for the home alarm system. And with this, if you were to click deactivate first off, it would instantaneously deactivate the software and it will give you a print prompt saying that your alarm system has been successfully deactivated and none of the following protocols or other lines of code would be activated, and basically just tell you to have a nice day. But if you were to type in activate, as you would want to for a home alarm system, then it'll give you this prompt where it says, please wait a moment while our systems check all entry points and camera feed. You'll wait 3 seconds as indicated by the sleep 3. And that's when you'll execute all this ifs and elifs lines of code, where it will check if door 1 has been opened, if the value is 1, representing that the sensor for door 1 has been activated or tripped. And it will either provide a 0 if it hasn't been tripped, and it'll give you the prompt saying that it's secure. It does this for door 1, door 2, window 1, window 2, and even the cameras. If it detects any motion, it will state that the cameras have captured an unidentified intruder. Or if it's 0, cameras haven't captured anything suspicious. It'll wait 2 more seconds to give you time to read all of that. And then it'll go into checking like an OR gate, as previously discussed. It'll check all the values of all the variables to see if any individual one is 1. And if any of them are 1 or if multiple are 1, then this line of code is activated. And it'll tell you that 1, it'll set the alarm alert status to 1 and prints out the alarm system has detected an intruder. It will now sound off an alarm and notify the authorities. And if it's 0, when all other variables are false and report nothing, then no suspicious activity is detected, and it'll give you an alarm alert status of 0. Give you 1 more second with the sleep function to read that. And the last lines of code will give you, if the alarm alert is equal to 1, it activates the alarm system's protocols. And with this, it'll give you a print statement saying the authorities have been called, the system has sent you a text alert, and an alarm has been sounded off. But if no alarms are tripped and there's no intruders, then it'll give you an alarm alert status of 0 and say that no authorities have been called, no SMS has been sent out to the homeowners, and no sirens have been sounded off. And this very last else statement occurs when you're supposed to enter either activate or deactivate, and you either mistype it or you don't type it in correctly or type in something else. Then it'll say that the system is sorry that it couldn't recognize any inputs, recognizing that you didn't either turn it on or turn it off, and it'll ask you to retype it in and restart the program. And going back to the slides, the very last slide, we decided after our first presentation, we wanted to implement multisim after hearing the instructor discuss that. And here we decided to add it to our project where we would be able to create a model/simulation of how our short logic gate system would work and demonstrate how we could get any and all possible outcomes from a truth table we made using the software. And first off, I want to say this, that the knowledge gained from how to use multi-system was directly from a YouTube video from Jeff Summey's channel, a professor at university. And here's a little URL link for that. But with that, I'll now take us to multisim and demonstrate how we're able to get that. Now here in multisim, using the free codes that the instructor provided with us, we are able to demonstrate what it would look like in a hardware aspect of how we set up our home alarm system. With the blue text right here showing a simple high frequency and low frequency switch with window 1, window 2, door 1, door 2, and cameras. And a low frequency switch would demonstrate that the system, the sensors haven't received any input and are not activated, therefore not receiving power from this 5 voltage power supply. But if I were to start the simulation, pressing that triangle right there, I have assigned individual keys to each of the switches so I can switch them on or off at any given point in time. And if I were to switch it from it being in an off state, which is this bar connected to this blue line, which is directly connected to a ground node, meaning that there's no power coming through. If I were to switch window 1 on, to the on direction, or if I were to switch C or any one of those, then that would demonstrate how the connection would then connect from the power supply all the way down to the 5 OR gates that we have. And it would send to this LSN receiver or output. And this output would basically represent the lights, the sirens, and the notification part of it. And also, these nodes or these electronic modules also show the values at any given point in time of the simulation. So if it's a 0 or 1, it would represent, as we stated before, it being 0 for false or the sensor didn't pick up anything, and a 1 for true or the sensor did end up picking up something. And also we have this, which is a logic converter connected to all of our inputs and variables and our output. And basically with this, we have a handful of useful tools that we can see. One, instantly it shows you a truth table, like the one we previously created ourselves, but does it in seconds. And you have also a couple of other tools and functions, as in converting one of our truth tables into an actual equation, or converting an equation into a simple circuit, or things of that nature. And basically we just use this to show the logic aspect of our programming and our software, as previously stated before, in Multisim, in order to demonstrate how we have full knowledge and know-how of how to use complicated things like this. And just stopping the simulation and going back to here. That would basically conclude the software aspect of this entire presentation. Alejandro?
Okay, well, that concludes our presentation. We appreciate you for watching. Have a good day.